Hello everyone, we have a problem for chapter 3 and it says that there is a bar with a length of 3 meters and then we apply a force of 5 kilonewtons. The force has an angle of 45 degrees with the horizontal. The bar itself is an angle with the horizontal with 30 degrees and the length of the bar is 3 meters. Okay, and then what is the moment about O? That is the question. It's also given that, so let me talk it later on the problem solution. So we have another angle which is 75 degrees. Okay, so if we know that the moment will be that the force and then times the arm. Okay, and then the arm here and the force, they should be perpendicular. Okay. So we talked about this one. So say that, so this is the, let's say, bar AB, and then we apply with a force of 5 newtons. Okay, and these two should be perpendicular. Okay, say that it is not perpendicular, that's another case. So we have a length of AB and the force goes this way. Okay, that's the force. Then we need to find, okay, so let's say that the question says that what is the moment about A? Okay, that's the question. So to find the moment about A, so what we need to do is that we need to find the arm of force that is perpendicular from point A. Okay, so but we also know that the vectors are infinite. Okay, so what it means is that, so actually not vectors, the line of action of vectors. So line of action of vectors. Okay, that is infinite. So it means that I can go this way. I can also do it like it here. Okay, it's not a, it doesn't change anything. Okay, I can do that. So in this case, since I'm looking for an arm that's perpendicular to force, so if I'm looking also for the moment about A, so I will start at A. Let me use different color. I will start at A, then I move up. Okay, and then I have the 90 degrees. Okay, so this will be the arm. Okay, that is the arm that I'm looking for. So this will be arm and that will be the force. So say that I know this arm, say that this one is 1 meter or 2 meters. Okay, and the force, I know, say that the force is 5 newtons. Okay, and then the moment about A will be that 5 times 2, that will be 10 newton meters. Okay, so one more time, the arm should be perpendicular to the force. Okay, so you cannot take this one as a arm for this force. And then if you want to check, this moment is a clockwise moment. Okay, it rotates this way in a clockwise direction. So I will say that this one is clockwise and therefore negative. Okay, since it is negative, I will say that the moment about A is 10 Newton meters. Okay, that's all. This is for, additional piece of information that we will need to apply it to our current problem. Okay, so I will start and then I will erase this part and then move to the current problem. Okay, so let's come back to our problem. So similarly here, the force and the bar, they are not perpendicular, okay? So I need to find a perpendicular arm to that force. As before, so what we will do is that extend it in both directions. Okay, we can do that. So extend the vector. Okay, I can do that. I did it. So then, since I'm looking for the moment about O, I will need to find a distance from O to point of application of the force. Okay, so I need to find a perpendicular distance. As you can see, this one is a perpendicular distance. Okay, so in other words, I need to find this distance D. Okay, if I know this distance D, I can find the moment by multiplying this distance to the force. Okay, so let's do that. This is the bar, okay, which is 3 meters. I have a perpendicular distance to force, and this one is 75 degrees, 90 degrees, and this one is the force. Okay. And 3 meters, 75, I know that this one will be 15 degrees, and this one will be that 3 cosine 15. Okay, 3 cosine 15, and the force is 5 kilonewtons, and then it means that the moment about O will be the force into the arm. Okay, and the force is 5 kilonewtons times 10 to the power of 3, and times the arm, which is 3 cosine 15 degrees. Okay, so if you can find it, so we can easily solve the problem. Okay, so let's look for what's cosine 15. So cosine 15 is 0.97. Okay, so if I go in 3 digits, it will be that 0.97. Okay, 967. So then the moment about O will be that. So you will have 5 times 3, which is 15, times 0.97, 967. That will be 14.5 times 10 to the power of 3 Newton meters. Okay, and this is the force, I mean the moment. But I know that this moment or torque is a clockwise. Okay, so it tries to rotate this one in a clockwise direction. So that is negative. So it is a clockwise moment. Okay, so that's all for this problem. But we can try another method, so that I will try in the second part of the recording.